All right, we're gonna finish up trig functions day 3 today. I was kind of surprised that no one emailed me any questions last night. Does that mean that you figured out the trig identity that you needed to use to solve those problems? I hope so. We have 2 kinds of problems left to finish today, and then as many mixed problems as we can have time to do. This first one looks like the quadratic equations we solved under objective 3 and objective 4. It's like 3 ugly squared minus 8 ugly minus 3. And so how do you think I would first attempt to solve it?
Are you showing anything on the screen or anything?
Okay, I thought I did, but I'm glad you asked. If you're not seeing it, let me see if I forgot to share screen. Yes, thank you. Okie doke, how's that? Perfect. Okay. So now that you can see it, how do you think I'd attempt to solve that equation? I gave you a big hint when I said it's like 3 ugly squared minus 8 ugly minus 3. How would you solve that equation? Nobody has any idea of something we could even attempt?
Try to factor it.
Thank you, Dominic. I was like, somebody needs to say factoring or I'm just going to lay down my head and go to sleep. Yeah, we can try to factor it. And as a matter of fact, since there are factors of 9 that have a difference of 8, that would factor. Let me just write this out to the side to make sure you understand what I'm thinking when I see this. 3 ugly squared minus 8 ugly minus 3 equals 0. If I can factor that, then I can factor this. And I've tried to get y'all to work hard on being able to factor by trial and error rather than having to go through grouping. This one's pretty easy by trial and error. 3 cosine squared would have to be 3 cosine x times cosine x. And this other 3 only has 2 factors, 1 and 3. So I just need to figure out whether to put the 1 here and the 3 there, or the 3 here and the 1 there. And since I've gotten pretty good at folding in my head, I can tell that it would take a 9 and a 1 to get an 8. I always put in my numbers and then figure out the signs. I want the 8 to be negative, so I want the outer terms to be negative and the inner terms to be positive. And then I'm never, ever going a step further without checking. That's 3 cosine squared minus 9 cosine plus 1 cosine minus 3. So I'm sure I have that factored correctly. And so far, I don't know why this is a different objective. It looks just like objective 3 or objective 4. I'm going to set each factor equal to 0. And I'm going to oscillate the trig expression. So in the first equation, I'd have cosine x equals negative 1/3. And in the second equation, I'd have cosine x equals 3. And now I see why it's in a different objective. What can you tell me about this equation? Cosine x equals 3. What angle?
It's out of the range.
Yeah, there's no solution to this equation because cosine is always between negative 1 and 1. Give you a note for that. Cosine x is always between -1 and 1 inclusive. So cosine never equals 3. What about this other equation? Can you squint hard and tell me any of the angles we have memorized on the unit circle that have a cosine of -1/3? No, that's not an x value of any of the ordered pairs we have memorized. Do you think there is an angle where cosine is -1/3? Yeah, it's between -1 and 1, so there is an angle whose cosine is -1/3. We just don't know what it is. How can we find the angle whose cosine is -1/3, or a decimal approximation of it?
Use the half angle formulas?
No, we can use a calculator. What function, the half angle formulas, Chastity, would be good if I was looking for cosine of an angle that was double some angle that I knew. But here I have no idea the angle whose cosine is -1/3. Actually, I have some idea because -1/3 is close to -1/2, and I know where cosine is -1/2. What button on my calculator gives me the angle whose cosine is -1/3?
The inverse.
Yes, yes, yes. Inverse cosine of -1/3 would give me that angle. And make sure your calculator is in radian mode, because the instructions are asking us for the answers in radians. So make sure your calculator's in radian mode and enter inverse cosine of -1/3. When I did that, I got 1.9106. I think the direction said round to 4 decimal places. Is that what you're getting? All right. How many angles should there be in one complete revolution of the unit circle? And again, we're including 0, but we're not including 2 pi. So how many times in one revolution of the unit circle should there be an angle whose cosine is -1/3? Yeah.
Twice.
There should be 2 quadrants. This is, okay, let me interrupt that sentence for just a minute and review something with you. Draw that, but don't label all the angles like we normally do. We normally have these axes labeled as 0, pi/2, pi, and 3/2 pi, but you have to remember that those are just numbers, and we could get a decimal approximation on a calculator. Well, that's still 0. No decimal approximation needed there. But for pi radians, that's about 3.14. What would pi/2 be close to? Would be half of that. It's about 1.57. And then 3/2 pi would be 1 pi plus a half pi. That's about 4.71. So when I say the angle whose cosine is -1/3, remember my calculator for inverse cosine will only give me an angle in or between 0 and pi. It either gives me a first quadrant angle or a second quadrant angle. Which one did it give me? Where's 1.9 radians?
Second.
Between one.
Yeah, it's somewhere between 1.57 and 3.14. I don't know exactly, but I've never really tried to get it exactly. That's my quadrant 2 solution. Somewhere there. Well, in what quadrant is another solution?
It would
Where?
be, wouldn't it be in the fourth quadrant?
Is that the other
Third.
quadrant where cosine's negative?
No,
It's the
that's the
third.
third.
Third quadrant. So there's going to be some third quadrant angle also. This is the angle that's 1.9106 radians. And I want to find the angle that is negative 1.906. Only I can't give negative 1.9106 as an answer because all of my answers are supposed to be between 0 and basically 6.28. So I can't give a negative answer. How could I find another name for this angle other than negative 1.9106? How could I find the angle that is 1.9-ish radians from the x-axis, or from, let's say if I'd continued around one complete revolution, that would be 2 pi. So how could I find the angle that's 1.9 radians from 2 pi? What about-
Subtract.
Oh, yeah. What about 2 pi minus 1.9106? And I got that to be approximately 4.3726. So again, if the directions didn't specify that my answers had to be between 0 and 2 pi, I could have just used positive 1.9-ish and negative 1.9-ish. But because my answers have to be between 0 and 2 pi, I just have to find another name for this angle, and another name for it would be about, I'm going to call this about 2 radians, from about 6 radians. 6 minus 2 is 4 point something. All right, let's do one more of those. Number 10, 5 sine square x minus 1 equals 0. Now, actually, I should have asked, does anybody have a question on 9 before we continue? All right. Then number 10, tell me the first 2 things you think I should do to solve that equation. Colby, can you think of anything?
No, ma'am.
That's okay. That's all right. We're learning. How about Emma or Elizabeth? Got any ideas at all?
I don't know if this would be correct at all, but could you take the sine squared x minus 1 and turn it into tan 2x? I doubt that would do anything.
Oh,
for you,
goodness.
but-
That sounds like it would be making it harder. I mean, I could change sine square x to a lot of stuff. I could change it to sine to the 4th divided by sine squared if I wanted to, but yeah.
Oh, wait,
Could
could you take the 1 over and then
That's what I was
square?
gonna, I was gonna say, could you add the 1, divide by 5, and then square
Yeah,
it?
absolutely. Even if I can't figure out what to do after that, I can at least oscillate the sine squared. Remember, this is just like 5 ugly square minus 1 equals 0. And if I gave you this one, you wouldn't panic at all. You would add 1 to both sides, you'd divide by 5, and then you'd do what?
Square root it.
Take the square root of both sides, not forgetting what?
That there's two answers, plus and minus.
Plus or minus, all right? You've got to train your brain when you see this and go, oh my gosh, I've never seen so ugly in my life. You've got to stop saying that and start saying, well, I wouldn't be freaking out if it was this. And I do this the same way, at least in the beginning. So we'd have sine square x equals 1/5. And then we would have sine x equals plus or minus square root of 1/5. And we could leave it like that, or we could rationalize the denominator. We're going to end up using the calculator anyway. So I would probably, just to make it easier to punch on the calculator, I'd say square root of 1 is just 1. But I'd probably not rationalize that because this is easy to punch on the calculator. 1 over square root of 5. Now this plus or minus tells me to expect how many solutions. How many times is sine going to be either positive or negative, something close to a half in one revolution of the unit circle?
4.
Yeah, once in each quadrant. And I need to find all solutions. So how do I find the first quadrant angle whose sine is, well, in the first quadrant, it'd be positive, 1 over square root of 5. Angle whose sine is 1 over square root of 5. It's a calculator button. It's
Inverse sine.
Yes, thank you, Kobe. It's inverse sine. I could say inverse sine of 1 over square root of 5. Find out what that is, and then use that answer to get the answers in the other 4 quadrants. Now, I got that to be about 0.4636. Is that what you're getting? I can confirm that that's in the first quadrant because it's between 0 and 1.57. And inverse sine always gives me an angle between negative pi over 2 and positive pi over 2. This is the one that's between 0 and pi over 2. So I have one of my answers. And it's somewhere in the first quadrant. I don't know exactly where. I suspect it's somewhere close to that, close to pi over 6. Because 1 over square root of 5 is close to a half, and sine is a half at pi over 6. So I'm not really trying to get it to scale, but there's something close. This is 0.4636 radians. Now, how do I get that same angle that's about a half a radian from the x-axis in the second quadrant, in the third quadrant, and in the fourth quadrant? Tell me how to get the one in the second quadrant.
Subtract pi from it.
Would I subtract pi minus 0.46 or 0.46 minus pi in the second quadrant?
0.46 minus pi.
No, in the second quadrant, I haven't quite made it to pi. Pi is about 3.14, and I'm about half a radian short of that. So pi minus 0.4636 would give you your second quadrant angle. Does that make sense, Dominic?
Yes.
I'm not, if I'm going counterclockwise, I'm not quite 2 pi yet, so I subtract pi minus the 0.46. I got that to be about 2.6780. All right. What about this third quadrant angle? I'm about half a radian. I'm just using for about a half. I'm using 0.436. How do I find the angle that's about half a radian past pi?
Would you add 0.4636 to pi?
Yeah, pi plus 0.4636 would give me the angle that's about half a radian past pi. And I got that to be about 3.6052. All right, one more. The quadrant 4 angle, and the reason we're getting 4 answers here is because of the plus or minus. How do you think we would find the 4th quadrant angle that's about half a radian short of being 1 complete revolution?
Subtract 0.4636 from 2 pi.
Yeah, if we had made it all the way around, that would be 2 pi radians, but we stopped about half a radian short of that. And I got that to be about 0.5196. All right, these problems, and I only have these 2 examples, but these 2 problems, you have to think about in what quadrant you should get answers, and your calculator is going to give you one of the answers. You should be able to figure out in what quadrant the other answer is going to be. Here, since we were looking for an angle where cosine is negative, my calculator gave me one of them, but I knew that there's another quadrant where cosine is negative. And I just had to figure out how to label that angle in such a way that it was a number between 0 and about 6.2 something. All right. Just when you thought pre-calculus couldn't be any more fun, I'm restarting with 1 because this is where our day 3 note started. We have e to the tangent x equals e. Y'all, in calculus, you see some of the most bizarre things. You just wonder where on the earth anybody ever needs to solve that. Well, I don't know, but there is, somebody does. Do you have any ideas at all?
Wouldn't you just set the exponents equal to each other because the bases?
Oh, that's beautiful, Emma. That's beautiful. That's e to the animal equals e to the duck. The animal has to be a duck. If e to the tangent x equals e to the first, then tangent x has to be the same thing as 1. And in what 2 quadrants is tangent positive? Where you have a positive divided by a positive in the first quadrant or a negative divided by a negative in the second quadrant. So I'm expecting an answer in quadrant 1 and quadrant 3. And I can squint hard enough. I don't need a calculator to tell me where tangent is 1. Tangent is either 1 or -1 at multiples of what?
Pi over 4.
Yeah, at my quarter pies, where x and y are either both square root of 2 over 2 or negative square root of 2 over 2. So the first quadrant quarter pi is just pi over 4. This third quadrant quarter pi is 5/4 pi. All right, you did a good job on figuring out a strategy for that one, Miss Emma. What about this one? E to the cosine x equals pi. In college algebra, we just finished solving exponential equations, and there were two kinds of exponential equations. They're the kind where you can write both sides having the same base. If you can write both sides having the same base, then you can just take the bases off and set the exponents equal to each other. So that's one way of solving an exponential equation. I don't think that's the case in number 2. I can't figure out how to write pi as base e. So what's our other way of solving exponential equations? We have a tool for getting exponents down out of the air. What undoes exponentiation? Somebody say logarithms.
Do you use
Logarithms.
natural log?
Yeah, you could use log base anything to unexponentiate. That's what logs do. But it makes sense if we're using a base e that we would take the natural log of both sides. So the natural log of e to the cosine x equals natural log of pi. What does that leave us on the left-hand side?
Just cosine x.
Yeah, that's natural log and e just undoing each other. Natural log of e to the ugly just leaves you the ugly. And natural log of pi, I'm just gonna have to leave that natural log of pi until I get the x by itself. When I get the x by itself, I will punch natural log of pi on the calculator. But what's it gonna take to find the angle whose cosine is natural log of pi?
Would you just do the inverse cosine?
Absolutely. I could check and make sure that natural log of pi is a number between -1 and 1, because that's the only way we're going to have an answer here. But even if I don't check it, if I just use inverse cosine of natural log of pi, if I get an error on my calculator, then I'll know, well, that must not be a number between -1 and 1. I got it. Oh, yeah, what are you getting for that? What's your calculator saying?
I have an error.
Yeah. And error, I can't spell and I can't think. Oh, Lord. I need a shot of something. Calculator. When your calculator says error, that either means you've misentered something or you're asking the calculator to do something that there's not a solution to. Well, here, there's no solution because natural log of pi is bigger than 1. There is no angle whose cosine is bigger than 1. All right. Still doing okay on time. What about number 3? Natural log of absolute value of cosine x equals negative natural log of absolute value of tangent x. Remember, those absolute values aren't really affecting the solution of the problem. They're affecting what you can let x be. Because of those, because you can only take natural log of positive numbers, those absolute values ensure that cosine x, absolute value of cosine x, is always going to give you a positive number unless it's 0. Nothing we can do about that. If cosine of x is 0, then there's just not going to be a solution. But the absolute value lets me use numbers that cause cosine to be negative, and yet I can still take the absolute value. Any ideas? In college algebra, we solve 2 kinds of exponential equations. Those where we can write both sides having the same base, and those that we cannot write having the same base. We have to use logarithms to unexponentiate. We also solve 2 kinds of logarithmic equations. Those where we can write both sides having the same base, and those we cannot write both sides having the same base. Well, both of these are base E. But there's only one thing I need to do before I can just take off the logs and say cosine equals tangent. Do you see anything that's keeping me from being able to do that?
Can you take the negative in front of the second log and put it in an exponent at the top, turn it into a fraction?
That's beautiful. I cannot take the logs off until I get both sides being single log, coefficient of 1, same base. Well, I know how to do that. That's put the negative coefficient back as the exponent. And I'm going to go ahead and, oops. Hey, what's wrong with what I just wrote?
You made the -1 part of the function.
And what does that mean? What is
But
tangent?
it's an inverse tangent.
Oh, that's inverse tangent. That's inverse tangent, not the same as the reciprocal of tangent. So if you wrote that, fix it. Tangent x in parentheses to the -1 is not inverse tangent, it's what?
Cotangent.
Yeah. So I don't know how many steps you need to write down, but perhaps it would help to say natural log of absolute value of cosine x equals natural log of cotangent x. Now I have both sides being single logarithms, same base, coefficient 1. And I can say if natural log of animal equals natural log of duck, the animal has to be a duck. Cosine x has to be the same as cotangent x. Oh man, that's still ugly. Any ideas?
Should we turn cotangent into cosine over sine?
Yeah, I really can't think of anything else to do. So let's try that. Cosine x equals cosine x over sine x. Then what?
Multiply by sine.
You can multiply by sign as long as sign is not zero. The way I would write that down is cosine x sine x equals cosine x as long as sine x is not zero. We will not be able to use 0 or pi as solutions because that's where sine is 0. Now, I just thought of something else we could have done at the beginning that would have made this way easier. But right now I'm illustrating that you don't always think of the easiest way to solve something. You can still solve it. Let's finish it this way, and then I'm going to tell you what I think would have been easier. And I'm going to speed up just a little bit on this one. I'm going to set it equal to 0 by subtracting cosine x from both sides. And then I can factor out a cosine x. So I want all the values where cosine is 0 or where sine is 1. Cosine is 0 at the half pies. And sine is 1 in the same place, the half pies. Actually, sine is only 1 at pi over 2, but we don't have to list that again. We already have it. There's a problem though. And Brady, this is similar to the one you asked me about last night. Brady sent me one that said, I got these 2 answers, but when I looked in the back or when I clicked check my answer, it's not including one of the answers I have listed. You always have to go back to your original equation anytime fractions are involved. And right here we had fractions involved, and tangent is a fraction. So anytime we have fractions involved, we've got to look at it and say, but can I use those possible solutions? Can I take tangent of pi over 2? Tangent's undefined at pi over 2. Tangent's undefined at all the half pies. So all of that work, and I can't use those solutions because they make tangent undefined. I hate it when that happens. Work hard, get a couple of answers, and I just can't use them because they make some part of the original function undefined. Now, let me tell you what I thought of that I could have done here. I think it would have been easier for my brain. Instead of putting that exponent back or putting that negative coefficient back as the exponent of tangent x, I could have, and I don't even know where to write this down. I could have added natural log of tangent x to both sides. And then how do I put back together the sum of 2 logs? Put the sum of 2 logs back as log of a product. When I wrote tangent as sine over cosine, the cosines would cancel and just leave me natural log of absolute value of sine x is 0. And then I could change that to exponential form. The base is e, the exponent 0, and e to the 0 would have to be sine x. And guess what that's the same as? Either way, you'd get answers you can't use. All right, that was number 3. Trying to think of, yeah, I think I better do 4 and 5. And then if we run out of time, because I know this is, I think one of the hardest things we've done this semester. And if you disagree with me, yay, that just means you're good at solving trig equations. But because this is, I think, difficult, wherever we run out of time, I'm just gonna keep recording and make sure I get these last 5 problems done so that if you're struggling in the homework, you can watch another, I'm guessing 20-minute video on solving trigonometric equations. These are all the objectives that were 1 through 7, but the problems are mixed together. So I'll have that other video. Yeah, I'll probably post it as a separate video on YouTube, just if you need it. All right, number 4. 7 to the sine x equals 5. Well, this is an exponential equation because the variable's in the exponent, and we already talked about how to solve an exponential equation where we could not write both sides having the same base. If we cannot write both sides having the same base, then we can use natural log to get that exponent down out of the air. Or log base anything, doesn't matter. I usually use natural log. So natural log of 7 to the sine x equals natural log of 5. And I can't say natural log of 7 undo each other. Like I said, natural log of base e undo each other. But what can I do? Why did I take the natural log of both sides?
You can put the sine x in front of natural
Yes.
log.
Yes, sine x, natural log of 7. And I'm just putting both of those in parentheses to make it really clear to my eyeballs that sine x isn't part of the argument of this natural log. Then what could I do?
Could you divide by the natural log of 7?
Absolutely. Natural log of 7 is just a number. I need to divide by that number. But I'm not going to touch the calculator until I get the x completely by itself. So what could I do to find the angle whose sine is this, as long as this is a number between -1 and 1?
Can you just take the inverse sine?
Perfect. X would be the inverse sine of natural log of 5 over natural log of 7. And I got that to be 0.9739. But can you think of why there's another answer? It's kind of like this one, where we had to use inverse sine to find an angle. And then we said, oh, there's not just one angle where sine is that. There actually are 4 angles if we include the plus or minus. This natural log of 5 over natural log of 7 is positive. You can punch it on the calculator by itself and see that it's positive. It's between -1 and 1. So this is my first quadrant angle, because it's between 0 and 1.5. In what other quadrant is there an angle whose sine is positive?
Quadrant 2.
Yep. So this solution is 0.9739 radians from pi in the first, or from 0 in the first quadrant. What angle is that same distance from the x-axis in the second quadrant? How could I find that angle? Oh, sorry, didn't realize you couldn't see my picture. I stopped almost 1 radian short of pi. How can I find a better approximation of that angle? That's 1, not, oh yeah, 0.97 is almost 1. So 1 radian short of pi. How do I find that? Just subtract that from pi. And I got that to be, what's that, number 4? I got that to be 2.1677. I wish I could tell you you will never run into things that ugly in calculus, but you will. And it's my job to make sure you're ready for it. All right, we may have time for 2 more. Number 5 is still under objective 7, but it's a little bit easier than number 4. Can you think of anything we can do?
Bring the 625 to the other side.
Okay, tell me why you're thinking of doing that, Dominic.
I was thinking of dividing, then as soon as I said that, I realized we couldn't.
You wanted to divide by that 5?
Yeah, but I
Yeah,
see we can't.
yeah. What kind of equation is that? When the variable's in the exponent, that's what? Exponential. And there are 2 kinds of exponential equations. Those we cannot write both sides having the same base, so we have to have logarithms. And those where we can write both sides having the same base. I happen to recognize 625 as a power of 5. 625 is 5 to the 4th. 5, 25, 125, 625. If I'm able to write both sides having the same base, then I can just set the exponents equal to each other. Tangent x equals 4. I'm gonna have to flip this over to solve it. Tangent x equals 4. How can I find the angle whose tangent is 4? The angle whose tangent is 4. How did we find the angle whose sine was that?
You do 4 and then the inverse.
We did inverse sine here. We need to do inverse tangent here. That's what inverse tangent does. It gives me the angle whose tangent is 4. When I enter that on the calculator, I get about 1.3258. What quadrant is that in?
quadrant 1.
Yeah, because it's between 0 and 1.57. It's in quadrant 1. In what other quadrant would I have an angle whose tangent is positive?
Quadrant 3.
Yep. Let's see. At 1.3258, somewhere in the first quadrant, and I know somewhere in the fourth quadrant, there's going to be another angle that's about 1.3 radians from the x-axis. How will I find that other angle that's about 1.3 radians from the x-axis?
You could add 1.3258 to pi.
Yep. And I got that to be approximately 4.4674. Sometimes I know math students don't want to write any words in a problem. They just want to only have numbers in a math problem. But this helps me figure out what's going on and what I'm looking for. I need to identify where is that solution I found, and is there any other solution, or are there any other solutions? All right. Since we only have 3 minutes left, and that's not even really time to start something, I'm not going to start these mixed review problems on this video. You're welcome to stay if you want to, but you absolutely don't have to. I'm going to make another short, my guess is 20-minute video doing mixed practice on all these objectives that we have. The 5.5 homework is due Monday, and also there is an extra credit assignment in my math lab for 5 bonus points on test 4. All right. Y'all let me know if you need any help this weekend. I will help you anytime except for Saturday afternoon. And I hope I feel better at Kroger Field in Kentucky. See ya.
I had a question, if you don't mind. So in like problems yesterday, if it ended up being like cosine x equals 2, we just crossed it out because we said that wasn't right, didn't we? So
Yes.
how can we do that with tangent?
Okay, that's a fabulous question. When you are graphing cosine, how high does it go?
1,
And how low does it go?
-1.
-1. Actually, that's more like sine than cosine, but yeah, sine only goes up to 1 down to -1. When you're graphing tangent that has its asymptotes at -pi/2 and +pi/2, what does it look like?
X cubed.
Does that answer your question?
Yeah.
You can take inverse tangent and inverse cotangent of anything, because tangent and cotangent go from -infinity to infinity, but sine and cosine only go from -1 to 1.
So in that problem we just did, if it was sine or cosine, it wouldn't be right.
If you type that on the calculator using inverse sine or inverse cosine, you'd get an error, and that's why you would get an error.
Okay, thank you.
Hey, great question. Miss Chastity, is there anything I can do for you?
Sorry, our
Okay.
computer being a little weird. I just wanted to let you know. I have one question on day 3, but I've got everything else finished on that assignment. Do you want me to just send it to you?
Day 3 of 5.1, the identities.
Yes.
Yeah, why don't you send me a picture, because you probably got way down in the problem before you got stuck. So let me see how far you got and then give you a hint to get unstuck.
Okay.
Just
All
send
right.
me a picture of that one problem. Email it, please, rather than remind, so I can answer on my computer.
Okay. All right. Let me scan it and then I'll send it to you.
Okie dokie. Thanks,
Thank you.
Jesse. Bye-bye.